We are going to solve Level 3 Integration 2018 Question 2E today. This is especially for Charles Guan at Bangare Boys High. Now, question E says the mass m grams of a burning candle T hours after it was first lit can be modeled by the differential equation like this. The initial mass of the candle was 140 grams. 3 hours later, the mass of the candle had halved. Find the length of time it will take for the mass of the candle to reduce to 50 grams. Alright, first of all, we have to solve this differential equation. Then we have to answer this question. When m is 50, we have to find t, which is time. Right? So let's do this. So we have to separate them. All the terms with m left hand side, others right hand side. So you see m minus 10 should be left hand side. To do that, you have to times by 1 over m minus 10 on both sides. Looks like 2. Right. So that means 1 over m minus 10 dm equals, well, then we times by dt on both sides. So what left is negative k dt. Then we integrate both sides. So 1 over m minus 10 into 10 becomes natural log m minus 10, right? Equals negative k becomes negative kt plus c. That's how you solve differential equation. Now, well, this is a log, isn't it? So it means m minus 10, knowing that m is greater than 10, equals what? E to the power of negative kt plus c. And now I can split this to negative kt times e to the power of c, isn't it? Then because c is a constant, I can just say e to the power of c is just say a. Right? So therefore, the mass is 10 plus a e to the power of negative kt. Right? So here we have to find a as well as k. So let's handle a first. Because we have this information here, initial mass, which means t is 0, isn't it? Is 140. So mass was 140 when t is 0. So 10 plus a. So e to the power of 0 is just 1. So just a. Hence a is what? Is 130. So we have this equation 10 plus 130 e to the power of negative kt, right? So we are going to find the k with this information. It says 3 hours later, the mass of the candle had halved. Now I just double check. T is in hours. Now, when I plug 3 into t, the candle must be 70, isn't it? Half of 140. So 70 equals 10 plus 130 e to the power of negative 3k. That way we can find the k. Now, 130 e to the power of negative 3k equals what? 60. So e to the power of negative 3k equals 6 over 13, right? So hence, in this case, we have to put natural log on both sides, right? So negative 3k comes front equals natural log 6 over 13. So that must be negative number, isn't it? K equals natural log 6 over 13 over negative 3. So that's the moment we need a calculator. So we go natural log, well, why don't I use this? I'm not sure whether you can see this. Okay, menu 1. Never mind. I'm gonna just do it by myself. Natural log 6/13 divided by -3 gives me 0.2577, say 8, right? So I complete the equation, which is m equals 10 plus 130 e to the power of negative 0.258t. So finally, we have to say when m is 50, we have to find the t, right? So to do that, we have to say 10 plus 130 e to the power of negative 0.258t equals 50. So that means 130 e to the power of negative 0.258t equals 40. So here, e to the power of negative 0.258t equals what? 4/13. Again, we put natural log on both sides. So that leaves negative 0.258t equals natural log 4/13. Hence, t equals natural log 4/13 over minus 0.258. Let's find it out. Divided by negative 0.258. So I've got 4.57 years, right? That should be the answer. Cool. Thank you and see you next time. 안녕.